All right, so number 8, please give it a read, pause the video. All right, so welcome back. Hopefully you attempted that problem. So I'll typically recommend drawing a normal distribution curve. It might help make things clear in case. So I'll just do that at the bottom. Right, sometimes this also allows for method marks depending on the question. But in any case, I think it's helpful to do this. So the mean is 25. And the probability that x is less than 24.15 is this. Okay, so I'm just going to arbitrarily put 24.15, and the probability of this area to the left of it is 0.1446. Okay, this is not to scale this diagram. I just drew it as I thought best. Okay, so now it says find the probability from 24.15 to 25. So we're looking for this shaded region right here in part A. Okay, so hopefully just by looking at the diagram, it becomes a little clear that all you need to do for part A is, to the left of 25 is 50%, so we just need to subtract this amount here. So 0.5 minus 0.1446, okay, and don't want to make a silly mistake here, so I'll just get the calculator, okay, and let's just maybe get a new document here. Okay, so this will be 0.5 minus 0.1446, okay, which is 0.3554. Into three significant figures, I'll just say 35.5%. Okay, part B, find sigma, the standard deviation of x. So typically, we need to find sigma, or the standard deviation, or if you need to find mu, the average. Typically, that is a good indicator that you will need to use this formula for normal distribution, the standardized normal variable. Okay, so so typically as a hint, if you need to find sigma or mu, you're looking at this formula. Okay, so I'm just going to write that down. B z is equal to x minus mu over sigma. So that's over here. Okay, so it says find the standard deviation, and we have the mean already as 25. So let's just put that in. Minus 25 over sigma. Okay, so the question is, can we obtain a z-score for something? And if we look at our information here, okay, we know that the probability less than 24.15 is 0.1446. So we can get the z-score just for this right here. Okay, so let's get our calculator out. The z-score, you can get that in menu. Statistics, where am I going here? Inverse normal. Okay, and the area was 0.1446, and the average was, oh, this is not what I mean to be doing. I'm not doing inverse normal. One moment. Actually, yes, I am. Okay, 25, and sigma is 1. Actually, sorry, 0, 1. That's what I want to be doing. Okay, so that's what I'll have there. Okay, so the mean being 0 and standard deviation being 1, that's like for corresponding to the z. Okay, so we have the z-score to be negative 1.0598 and so on. Okay, so negative 1.0598. I'll say dot, and we'll use the exact value later. And x was corresponding to, we did that at 24.15. 24.15. And we should just have something that looks like this. Okay, so just a note here. Why I like the diagram as well is that this is for the original distribution, but if you wanted to look at the corresponding z, I'll change colors here. Let's just go with this. Okay, so this would be 0 in terms of the z, and the sigma would be, the standard deviation is 1, which allows us to find the corresponding z value for this. So what we just found was negative 1.0598 ... Okay, and now we have to find sigma for the original curve, okay? Because sigma for this, okay, so let me be clear here. For the original, mu was equal to, not the original, sorry, for the z-score, mu is equal to 0 and sigma is equal to 1. Now we want to find the corresponding values for the original curve where mu was 25, and now we want to find sigma, and that's what's happening here in this formula, okay? So we have to do the numerator, and then we're going to end up dividing by this. So let's just do that over here. 24.15 minus 25 divided by the previous answer. So it should be this. So therefore, sigma is equal to 0.802 to 3 significant figures. Okay, and that should be that. All right, so, okay, that was just part I. Okay, the next one, part 2, hence find the probability that a seashell selected at random has a length greater than 26 millimeters. Okay, so now that we have the information for sigma, we can now use that in our normal distribution, the normal values with the random variable x. Okay, so let me maybe just also write here that now we have the mu is 25. Okay, and we've also just found that sigma is equal to 0.802. Okay, so that's our new information. So part 2, we can do this purely on a calculator. As a length greater than x is 26 millimeters. Okay, so what we're trying to do is find the probability that the random variable is greater than 26. And let's get out the calculator. Okay, so menu, let's go to here. And we are looking for normal CDF. Okay, so the lower bound in this case is 26. Okay, upper bound, you can put infinity, 9999 would work. Okay, and the student actually is the one who showed me about the infinity. I think you can get that from here, and it should work. Okay, but in any case, 9999 would work as well. The mean was 25, and the standard deviation is 0.802. I ideally would have more digits here. I did not save that value or recall what it was, but let's just go with that for now. It was actually this. So maybe if you want to, in case there's a rounding error here, let's go back and maybe just write. Okay, oh, that is not what I wanted. Okay, let's copy that. Okay. What am I doing wrong here? Okay. Let me go back to normal CDF and see where I'm messing up. Okay, 5 distribution is normal CDF. What did I do wrong? Okay, so let's do lower bound again. I'm just going to do 999. The mean was, oh, of course, 26 gave me 50%. Okay, so the mean was 25. I must have put that as 26 if the mean was, if it was giving me 50%. So I think that's where my mistake may have been. 0.802. Okay, so that makes more sense. So yeah, I should have just seen it right here. I accidentally put 26 both times, so it just, of course, that's 50%. Okay, so anyways, this is the value. The 3 significant figures, 0.106. So again, if you want to be more precise, let's bring this down and copy this number just to make sure that it is exactly, it doesn't change anything. Okay, and it doesn't. All right, so 0.106. Okay, so the next question, let's come here. A random sample of 10 seashells is collected on a beach. Let y represent the number of seashells with lengths greater than 26 millimeters. Okay, so we know that the probability, we just found the probability that it's greater than 26 millimeters to be about 10.6%. Okay, or 0.106. the expectation is going to be the probability times the number of seashells there are. So just this value times 10. So of course we should know what this answer is, but I'll just show that anyway. It's 1.06. Okay, so let's write that down. Maybe it's getting a little messy here, but C, the expectation of Y is equal to 10 times 0.106 dot 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 dot, which is equal to 10.6 per, oh sorry, not percent, just 10.6. And I can't multiply, that's clearly 1.06, 10 times that. Okay, let me erase that. 1.06 to 3 significant figures. Okay, so D, find the probability that exactly 3 of these seashells have a length greater than 26 millimeters. Okay, so exactly 3 of these. Now, if this is, if the probability of just one of them is 10.6%, okay, well then the probability that you don't have that is just 100 minus that percent. So this is actually a binomial question. Okay, so once again, 10.6% for it to happen, and the opposite of that, so about 89.4% is the probability that you don't have that. Okay, so D, let me just write this down. Okay, it's a binomial distribution with Y, and the percentage is 10.6, so 10.6% is how I'll write that. Okay, so we just need to go here. Let's go to menu, probability, distributions, and we're going to go to A. Okay, number of trials. I'm already forgetting there was what? Out of 10 of them, yes, 10. And probability is, I keep on, did I copy and paste it? No, it's not there. Okay, so 0.106. Ideally you have a few more digits there, and we want it to be successful 3 times. So this should be it. Okay, now I don't like the fact that this is rounded. Maybe something will change, so let's get the more precise value. So instead of 0.106, it was this one. And let's see if it makes a change. Oh, and it does to 3 significant figures. So here's an example where to 3 significant figures, it actually, using the more precise value, it changes this answer. Okay, all right, so that's 6.55%. So probability that Y equals 3, like there's 3 of them that show up, is 6.55%. Okay. All right, so the last one, a seashell selected at random has a length less than 26 millimeters. Find the probability that its length is between 24.15 millimeters and 25 millimeters. Okay, so we know that it's less than 26. So thinking of that, maybe I'll draw on this same diagram here actually. I'll do it in green. 26, let's just say that's 26 right here. So if it's selected at random, if we know it's the green now, we can ignore this part over here. So we already have the probability that x is greater than 26 to be 0.106. So we have to take the opposite of that because we're only considering this range now. We're not considering all 100%. Okay, so 100% minus this 10.6% will be our denominator. So it's pretty much a conditional probability. I strongly recommend you understand the formula, then just going straight to the formula. But if it helps, I mean, this is technically what we are looking at. Okay, probability of A given B. And the denominator is this green area that I'm looking at here, less than 26 millimeters. Okay, and find the probability that it's in between 24.15 and 25. So I think we already have that from somewhere. I mean, it's whatever this value was. And that was this 35.5%. Okay, so maybe I'll just show the work right here in green. So this is E. So the probability, okay, that it's, let's see, between 24.15 and, okay, so I'm going to say, I'll write it out like this, 24.15 less than x less than 25, given that, what is it, x is less than 26. Okay, and this is quite ugly actually, like it might confuse you. However, just know that what I'm doing is I'm just trying to write it in this kind of notation. But if you just understand it, like hopefully you don't get caught up with the notation. So if this confuses you, perhaps don't like get hung up on this. But let's just go with the denominator needs to be this whole green area less than 26, which is this part, x is less than 26. And that is, what was 10.6? Okay, so 100 minus 10.6%. Okay, because this is 10.06%, and the numerator is just this little part here, which is 35.5%. Okay, so let's just work that out. Okay, so, oh, wrong one. We have 10.6%. So where is that coming from? This one. Okay, and then, oh, that's in the denominator, so that should be down here. I'm making a lot of little calculator mistakes here. Okay, but we can do 1 minus this. So I'm converting it now to, why isn't this copying for me? Let me try this one more time. Okay. Huh, strange. I'm not sure why it's not copying for me. I'll just write this for now. Okay, and the numerator was from 0.3555, this one. Okay, it's not copying either for right now for some reason. Okay, it should. So this is the answer. And to 3 significant figures is 0.398. 0.398 or 39.8%. Okay, and that should be everything. The official mark scheme, if you want to take a look, is here. Okay, hopefully everything matches up. We had this, I believe. Yes, everything looks good.